What's up, everybody? Welcome to Maths with Gaston. I am Gaston Mapala right here at Maths with Gaston. Today let's have a look at question 3, November 2022, grade 12. It was an analytical geometry question, very interesting. Please pay attention and follow through. If you don't follow, please let me know on the comment section below which part of this question you may have not understood. All right, great stuff. Now let's go ahead, read the question. It said in the diagram we've got A. It's at 4.2. There's A there. It's 4 and 2. It's X and Y. Then we've got B. There's B here. We see that B and A, they're in the same line. C, verticity of triangle. Okay, there you go. So they just given us this one here as a triangle. We see that it's clear on the diagram. T is the midpoint of CB. Okay, here's the midpoint here. I'm just gonna put M, say midpoint, so that I don't forget this one. All right, and then said the equation of a straight line of AC, the equation of this line is given by 5x minus 6y is equals to 8. Very important information here. And then the angle of inclination of AB is given by theta. There it is. We see that this angle, it's the exterior of this triangle here. Great stuff. And then triangle DCT, let's go and see it. Okay, here it is. I'm gonna mark it different here with a different color, this triangle. Okay, let's mark it with a different color. Okay, let's come here, mark it with a different color. Okay, we also go to triangle DC, and therefore T. And then again we have got another triangle as well. Before we can go further with the question, I can already see that we've got another triangle here. Let's rather mark it. We've got triangle here at F, R, and therefore A as well. Okay, good stuff. I think it's visible with the dots that we've made. So let's move right along and read the question. It says triangle ADC is drawn such that CD, okay, here's a CD here, is parallel to this. These two lines are parallel to each other. Great stuff. The line AC and DC intersect at S. Okay, we see that. Y-intercept of AC, where is AC? There it is there. FTR are in the X-intercept of DC. Okay, BC. I think here basically this information here, they're just telling us that this line, they form a angle of inclination with the x-axis. It means here you've got an angle here, you've got an angle here. If you know the gradient of DC, you would know this angle. If you know the gradient of AC, then you would know this angle here, and then also we've got this angle right here. So these are all the angles. Remember, these are all the angles that are formed by the angle of inclination. Okay. Number, what is the definition for the angle of inclination? Is the, already discussed it in previous videos, guys. It is the angle that the line forms with the x-axis. Okay. This is the angle that the line forms with the x-axis. Okay, I think we're ready now. We have gone through everything. Let's go ahead and deal with question 3.1. This question is divided into 5 questions, 3.1 up until 3.1 up until 3.3. all right, okay, let's move right along. And then it says calculate the gradient of AB. Okay, what are the points of AB? Let's come here. 3.1.1 coordinates of A, they are given by 4, 2. Therefore coordinates of B, they are given by 6 minus 4. Okay, we know the formula for calculating the gradient. Gradient of AB is going to be given by y at B minus y at A minus x at B minus x at A. Even if you say y2 minus y1, still the same, guys, still the same thing, as long as you can follow through on what you are doing and substitute correctly. There shouldn't be any problem with that. Okay, our y at B is negative 4 minus our y at A is 2. X at B is 6 minus 4 6 minus 4. Okay, therefore let's come here. Therefore our answer would be, punch this in our calculator, we found that our answer is minus 3. Right, great stuff. Okay, so now we come to 3.1.2. we just calculated the gradient of this line here. We know the gradient. So now they're asking us to calculate the size of alpha. Alpha, it is the angle of inclination of AB, which is the angle that line AB forms with the x-axis. All right, guys, what I'm saying, you can note it down and write it down, okay? But this is just a little bit of theory behind it. Okay, we know that a gradient of any line, which in this case is AB, is going to be equal to tan angle of inclination. This is there on your formula sheet, guys. So in this case, what we have got minus 3 is equals to tan alpha. So therefore alpha would be equals to tan 3. You would notice that I have removed the negative there. There's a reason why I'm doing that, guys. Let me see, let me just double check something. There's a reason why I am removing the negative 3 there, because what we are doing, we are looking for instances where it's negative. In some case you can put the negative here, guys. It's not a problem. Let's rather put it anyway. It's not a problem. So therefore our alpha reference, which is the reference angle, this one is going to give us negative 7.7157. all right, so therefore you say tan is negative on which quadrant? Tan is, let me rather write what I'm saying here. Tan is negative in quadrant 180 minus whatever the angle we are getting. Okay, you see why I wanted to take out this negative here. So therefore it means our alpha is going to be equals to, this is alpha reference, I'm sorry about that, is going to be 180 minus 7.50. so therefore our proper angle will therefore be equal to 108.43. okay, I know, guys, here rather leave the negative out so that you get it as in 70, because I know you are going to be asking me questions why, but you just have to remember that you need to include the negative and calculate where tan is negative. Okay, in this part in analytical geometry, guys, if it helps you, you can cram it, because it comes a lot where you find that your gradient is in the negative, but if it's in the positive is fine, but if it's in the negative, you need to account for that negative. And how do you do that? You always calculate without the negative, and then you get the reference angle. Then the reference angle will therefore give you the angle that you are looking for. All right, so we already got this one here. It's 108.43. carefully putting it there. Right, great stuff. So moving right along, the coordinates of t. Now to calculate the coordinates of t, we know that t is the midpoint of CB. Okay, let's come here. 3.1.3 coordinates of C, it's minus 2 minus 3. What is it that B is 6 minus 4. Okay, so therefore midpoint, capital letter MCB, is going to be given by x at B plus x at C divided by 2, y at B plus y at C divided by 2. Close bracket is going to be equals to, okay, now we can substitute our coordinates here. Let's see, what do we have here? We have got okay, now I made a mistake. Okay, now it's fine. We have got minus 4. Okay, no, well, we're saying x at B, not this one. That's not correct. Excuse me, guys, you need to substitute correctly. X at B is going to be 6 minus 2 all over 2. Y at B, it's minus 4 plus and 2 minus 3 divided by 2. Close bracket. I'm running out of space here. Therefore, the coordinates of mt, which are the coordinates of t here, they would therefore be equal to 2 is to negative 7 over 2. Okay, great stuff. And that's just application of the midpoint. And then 3.1.4, it says that we need to determine the coordinates of S. Where is S? S is the line of intersection. What did they say here? Let's go back to the question. Line AC and DT, they intersect at S. So therefore, this is the line of intersection, which happens to be the y-intercept of line AC. All right. So therefore, if you go to equation of AC, it is given to us that AC is this one. It is given by this equation here. So therefore, what you can do, when do you get the y-intercept of the line AC? Let me just put here, this is line AC. You get a y-intercept. You will remember this from our functions, guys, when x is equals to 0. So therefore, we're going to make 0 into our equation. We will substitute 0 there, minus 6. Y is equals to 8. And therefore, this 5 times 0 will be 0. Therefore, we're looking for y. We are going to divide both sides by negative 6. Negative 6. Y is therefore equal to negative 4 over 3. Okay, with that, and then therefore we know that therefore S would be 0 is to negative 4 over 3, which makes sense because it is an intercept. I know, guys, there's many ways you could have attempted to get this one, but this is the easiest and straightforward way of getting it based on the information that is given on this question. Okay, let's move right along to 3.2. Okay, here we are at 3.2. I hope you didn't forget the things that we calculated there. I'm just gonna put them here. We know that here we have got the lines of inclination, and then we already know that this is 108, 43 as our angle. I think we're going to need it as we move along with this question. We already know the coordinates of this one is 0 is to negative 4 over 3. See, guys, I'm filling it in. You can also do this in the exam. You write on your question paper as well. Okay, coordinates of the midpoint here, we already got them, is 2. Just in case going further you need this information, guys, and also for the sake of this lesson, so that we don't keep going back to what we did previously, I'm just gonna put it here. Okay, make sure all the information, we make sure that all the information is here. All right, great stuff. So 3.2, determine the equation of CD in the form of ym, which is the gradient. So this is a straight line. This is our straight line here. All right, so line CD, we've got CD. So is this line here? They are asking us to calculate this line. Okay, but remember from the previous question, we did calculate that this AC has got a gradient of, AB rather, has got a gradient of -3. And therefore, we know from the equation, from the information that was given on this question, that AB, we know that, let's rather continue here. We know that CD is parallel to AB. So what do we know with parallel lines? Therefore, we know that the gradient of CD will be not parallel but equal, will be equal to the gradient of AB, because the lines are parallel. Okay, all right, so therefore we know there's a point here that is given to us, which is point C. So having the gradient and one point, we are therefore going to be able to calculate our equation using this formula here, which is there in your formula sheet, guys. CD x minus, or rather y at C x at C, close bracket. What are the coordinates of C? Coordinates of C is -2, is -3. Okay, so with that, let us substitute this into this equation here, right here. Okay, our y minus into minus y at c, which is minus 3, is equals to the gradient minus 3 close bracket x minus into minus. Please don't forget the negative signs, guys. This could be really a nightmare if you don't account for them, okay, because they have got a potential of changing the sign. Plus negative sub negative plus 3 minus is equal to minus 3 x plus 2. Therefore we can remove the bracket there. Now it's going to be minus 3x minus 6. Then you take the 3 to that side of the equation. Is going to change the sign. It's going to be minus 3. Therefore our y at CD is going to be equal to negative 3x negative 9. Great stuff. And that's how you would deal with a equation like this one. All right. Okay, moving right along, let's come here now. Let's look at, okay, we're done here. I'm just gonna put a straight line here because I can clearly see that we're running out of space here. Okay, let's come here and deal with 3.3.1. It says calculate the size of angle C, DCE. Okay, let's come here and see. I think we need to mark this whatever they're asking us here. Let's use blue. All right, they said look for DCA. So what are they looking for? They are looking for us to calculate angle C. Okay, they are looking for angle C. Angle C. Okay, they are looking for this one here. Looking for this one here, which is angle C. Okay, so therefore this is what we are looking for. So what can we do from this? I can see that we need to find F. Okay, we need to find F, and then knowing F we'll be able to find CA here. Once we found A, because these two lines are parallel, I can already see something like this from Euclidean geometry, guys. I know, I'm sorry for bringing it up here, but it is a reality here. So I already see something like this already. You remember the fan angles, okay? Alternating co-interior angles, okay? So now if you can see, let's say this is D, therefore this is C, therefore this is A, and therefore this is B. Can you see that if you know this angle here, it's equal to this one? Why? Because they already told us that CD and AB are parallel. These two lines are parallel, therefore this you will have these ones which are alternating angles. So now let's go ahead and look for angle F. Okay, I think we must start with F here, and F already they gave it to us because we know the equation of straight line AC. All right, okay, so I'm gonna continue with the blue color here. We know that okay, sorry about that. We know that it is given to us in this question that the equation of a straight line AC is 5x minus 6y is equals to 8. So therefore we need to solve for y. If we take this one to the other side and make y the subject of the formula, we are going to have minus 5x plus 8, divide everything by negative 6. Therefore y is equal to 5x over 6 plus, if you simplify this one, okay, let me rather leave it like that, 8. Okay, it's gonna be negative here because we're dividing by negative 6. Thank you guys for showing me that. Divided by 6. Great. So now we know the gradient. This is the gradient. This is for line AC. Okay, so it means this one will give us this angle here, angle F. All right, so we can come here and say, if we're looking for F, the gradient of this line of AC should therefore be equals to tan angle F. Okay, So therefore you already know what is this one. It's 5 over 6, each equal to tan f. Okay, so therefore we can come into our calculator therefore and say angle f, it is therefore given by tan shift second function 5 over 6. Okay, therefore here we go. Therefore after we do that, is going to give us, it's already positive, guys, so there's no need to worry about negative and accounting for the negative on this one. Therefore our angle, if you punch this our calculator, we get in 39.81 degrees. Okay, so that's what we got. So now we have got this angle here, which is 39.81. okay, therefore great stuff. So now with that, we can come here and say either there's two ways to do this. Either you use this rule of saying exterior angle, okay, exterior angle of triangle is equal to sum of interior opposite angles. This is there in Euclidean geometry. You can apply that. What is the exterior angle of this triangle? Which triangle are we referring to? We can come here and say triangle AFR. I hope you guys can see it. I'm looking at this triangle here. I'm just gonna mark it in blue. There you go. Okay, so you're looking at this triangle. What is the exterior angle? The exterior angle in this case, it's a alpha, which is there at R, okay, is equals to internal opposite angles, okay, plus F. Okay, so we know this one is 108.43 is equals to A, we don't know what is A, plus we know what is the exterior angle here. We know, no, we just calculated F is 39.81. So therefore it means angle A is going to be 108.43 degrees minus 39.81. Okay, therefore we'll come here and say therefore A is going to be given by, in our calculator when you put this, I'm getting 68.62. But you say no, wait, sir, there's many ways you could have done this. Yes, there is many other ways that you could have done this. If you would like to see other ways of doing this, please let me know. Therefore we would deal with them together again. All right, so I'm not going to show the other alternative way, but I will describe it now. Okay, now with this, now that you've got A, there, it's 68.62. If you've got A, therefore what did we say? We said because A and B and CD, they are parallel, therefore C is equal to 68.682. Reason being these are alternating angles, and then why are they alternating? Because CD is parallel to AB. Guys, with this one you are gonna get 100%. You're definitely gonna get the distinctions if you can fully understand it. I'm trying to be as slow as I can so that you fully understand, but you said okay, no, I did promise you that there's another way of doing this. What you could have done, I'm going to need another color to illustrate this. Okay, now let me get another color for you guys to be able to look at this one. You could have done this differently. Okay, what do I use? Don't want to use blue, already got blue there. Okay, let's use this red. Already here, guys, you already know that if you've got an angle that is on a straight line here, the sum of angles on a straight line that equals to 180. So you could have actually calculated this angle R here, okay, by simply saying 180 minus this angle here. Okay, then you could have gotten this one, and then after getting this one, you will have F, you're gonna have R here as well. A will be unknown, therefore you know the sum of angles in a triangle that equals to 180, therefore you could have easily gotten angle A there. All right, I hope that's clear and straightforward, guys. So let's move right along and then do question 3.3.2. all right, come here. I'm just going to continue with this color here. Okay, I think everything is clear, guys. All right, moving right along, they're asking us to calculate the area of POSC. Okay, where is a POSC? There is a P is here. Where is O? Is here. Where is S? Is here. Then there is C. So they're basically asking us to calculate this right here. Okay, so what can we do? What we can do here, we can take the triangle, the area of triangle FPC minus the area of OFS. Okay, now let's have a look at this one. What are we saying? We're saying F, here it is F P C. Okay, so we can calculate it, this triangle here. We can calculate the total area of this triangle including this part here, but we need to remove the other part. Okay, we need to remove this smaller part here. Okay, basically guys, what is happening here, let me draw it here for you. You have got this one. I'm gonna try to make it as possible, because I know this could be very, very tedious, guys. So that's why I'm taking my time to explain this to you. All right, the only thing you can do for me is please share this video with many of your friends so that they also can fully understand what is going on here, and then we don't struggle alone. All right, okay, here we go. They've got C there, we got S here, then we've got F there. Then what is this one? This one is O. Okay, guys, so what is happening here, said we calculate, we just need to calculate there, we need to calculate here the angle of the bigger triangle. Can you see the bigger triangle? I'm going to try to make lines here along the bigger triangle, which is FPC, which is this one that I'm highlighting here. Now this is the bigger triangle. Okay, so you calculate the area of the bigger triangle, but you need to minus the smaller triangle. Which one is the smaller triangle? Let me show you guys here again with a yellow color, hoping that this will be visible. Okay, then you need to minus the smaller triangle, which is this one here. So you see bigger triangle minus this one. So what is left? You are left with this smaller one here. Okay, so you would have eliminated this smaller one here, therefore you are able to get the area of POSC. All right, okay, so let us continue here, and then we will see now. Let us continue here, then we will see now. So therefore we're going to say the area of a triangle is given by half. Okay, is given by half base times height. So now on this triangle F, P and C, we calculated the height. Yes, I have calculated the height, guys. You can go ahead and calculate the height using the distance formula. In this case, I'm not going to show it, but we'll show it in the other example. Then the height is 3 minus 1 over 2, which is the height, is the base is 1.6, and then therefore we have got 4 over 3 here. If we punch this into our calculator, we are getting 6.9 minus 1.07 is equal to 5.83 unit squared. All right, and that's how you would deal with a question like this one, guys. Unfortunately, I don't have enough space for me to show how to get these ones here, the height and the base, but guys, you can use the distance formula to get these ones. Okay, if you still don't get it, please drop me a comment on the comment section below. I will be definitely be more than happy to assist you to get it as well. All right, I am Gaston Maphala. See you on the next upload, where we'll be doing November question 3, November 2021 grade 12 maths paper 2.